So my name is Jorge, as Paula says, and thank you everybody, all the organizing committee and people from EULAC-PerMed. I think I don't need a mic, but I mean, I'm used to teaching big rooms. But anyways, so when Paula talked to me about this, because we met in Barcelona, and I proposed her a couple of topics from research stuff till introductory stuff, let's say. And she picked, and I think wisely, this part because, thank you. So, because at the beginning, we have started to put everything like together and what data science is and how artificial intelligence comes to play. And so that's what we are aiming with this talk. But if you want to talk about deeper things, and let me know, and that's kind of what we do. So the agenda that I have for this small talk, we're gonna just throw a couple of personal information from both of us. We want to talk about a little bit about what is data science and some of the problems that we solve using data science. Uh, what is supervised learning, unsupervised learning, and some around the medical image processing. And we're gonna draw some conclusions afterwards. So, well, in my case, this is me. That's my email address. In case any of you need to contact me after this, if you don't like it, you don't have to contact me. But anyways, so I have a BS in electronics and computer science from University in Guatemala, and then I got a master's in operations research, also in the University in Guatemala, where I work now. Then I went to Texas A&M to get a master's in applied mathematics, and I got a PhD in industrial engineering at Purdue University, where I work also nowadays. So I'm an off-campus faculty of Purdue. I advise people. I have a couple of PhD students at Purdue. And I'm a professor of mathematics and operations research and statistics in Galileo University, and I'm the director of the Operations Research Institute at the same university, where we do research around data science and the potential applications. Also, I have a consulting company in the area of data science and optimization, and I have some research interest thrown there. Something that I never say in any talk I have said, I'm a dropout from med school. So this area came really fit for me because I started med school. When I was about to start my third year, all my profs were, you should go into math, because I was doing really good at statistics and math and all that, and suffering biology, anatomy, and all those. And then, well, after all my family, I think, talked to me, and I decided, okay, I'm going to switch off to engineering. And, well, I would have studied math, but I didn't realize that math is what I wanted to study. But anyways, so I went to the engineering school and say, which program has more math courses? And they say electronics. So okay, electronics it is then. And that's how I picked my major. So anyways. Then is here my colleague, Frank Viva. We work together. He has a BS in mechatronics engineering, a master's in operations research, and a master's in industrial electronics. He's also a prof in statistics and operations research. Even though he's really young, he has a lot of experience in data science, and he's among the best students that we have produced. I am the director of the operations research program. He's really good at what he does, and really amazing in all the different roles that he's going to talk a little bit in when it comes to the data science analysis process, let's call it like that. And something that's worth to mention is the first time he's going to give a talk in English, so you should be nervous. So anyways. So a lot of people have asked me, what is data science? And I have given a couple of talks around what data science really is and the difference with artificial intelligence. And to talk a little bit about that, we're going to start off with, the need of data science. And they say that next year we're going to be producing around 1.7 megabytes per second per person. And I see a couple of people that are older than me or my age. And you all remember that the small discs that we used to have, and it was really cool when they came out with the small version, because they had the 5 and a quarter, I think it was what they call it, whatever. And then we had the 3.5, and it was really cool. And it was 3 megabytes. So if we think about it, it's throwing how many? Every 2 seconds, one of these disks the floor per person, you know. So it's a whole bunch of data that we are producing. And I found this really cool graph with a lot of facts. I'm not going to read them all because I'm going to get into the stuff, the good stuff soon. But I think they have a couple of nice statistics that are exciting about the necessity of data science in our world. And they have things like YouTube. Sorry, I'm growing up. Anyways, YouTube, they have 4.5 million videos being watched. That is in a minute. Everything, all this data is in a minute. 1 minute in our current life. We have 4.5 Google searches per minute. So they have this amazing thing that I didn't know about, like hashtag love is used 23,000 times per minute. So analyzing some of this is super cool. And you know, why does data science become a thing? Because for those who are working in the math, it's all math. We are using really old math. But why is it became a thing? So what I have here is like a short timeline, and it started with people working on decision support systems, people working in operations research and these related areas on decision making. And then, well, that was around in the 60s. And when you are working in a decision system, or in terms of in theory, you need a lot of data. So they started, you know, with the need of having a lot of data, and then computers came to play, and that made the algorithm being now have a home where they can be implemented, but they need a lot of data. And then the problem of data warehousing came to play. And if you remember, in late 90s and early 2000s, who had the thumb drive with more capacity was really cool. And we were really excited. I bought one of 32 gigs. It was like a cool thing. Nobody does that anymore. I mean, it was something important that is not important anymore because the problem of storing is solved. We don't talk about the storing anymore. But the thing is, oh, there's always opportunities, still research going on. I mean, we still need to grow because this is moving so fast. But my point is, storing data is not the main issue nowadays, because now I have so much data that we need to get into what to do with the data. And then it came the so many different names that we have, like big data. And then eventually data science has been placed as the science of data analysis. But there's also the thing with artificial intelligence. And I have to give a talk recently because I'm recording, I'm doing a video in EDX on artificial intelligence. I need to make sure that I clarify the difference between data science and artificial intelligence. And I think I'm going to hope to do that here as well. But anyways, so this graph, which, by the way, was done in 1996 under a project similar than this by the European Union. It was the European Strategic Program on Research and Information Technology. And 10 years later, they switched the name, and the name of this model is the Cross-Industry Standard Process for Data Mining, CRISP-DM. And they came up with this in order to explain more or less how the data science or the data analysis process more or less work. So this works as follows, and we have a business understanding guy, and then we have someone understanding the data. And speaking of this area in particular of personal medicine, or talking about medicine, we have here whoever understands the need in the medical field, and whoever understands the data, and they have to communicate and eventually come up with ideas or whatever. And then this guy, the data scientist, let's call it, prepares the data, do some modeling, interacts a lot here, and then eventually comes to an evaluation, and together with whoever has the business understanding, they will throw some deployment, and then you have some monitoring. I remember at some point, because I didn't know about this one, this, let's call it framework, I came up with my own, and I was teaching in a class, and someone, hey, why don't you use the CRISP model? So I just like this better than mine. But I think this explains pretty well how the cycle of this data analysis works. Um, so continue what Jakes was saying. When we think, how do we think? I mean, actually, my PhD is more in decision making, and this is a really simplistic decision making process. And our brains gather information of so many different sources and video, audio, and so many other things, and some way magically make sense out of the data, and we make decisions. So the question is, how can we do, or what do we have to do in order to do a computer to do the same thing? So where data science comes to play is in that part, putting all the sources together, trying to make sense out of the data. And this is not simple, though. I mean, but that is one of the issues actually that we just, well, Jakes was discussing, and how to put all these different sources together and how to make sense of the data. That is using all of these models and algorithms, and eventually we make decisions. In data science, we don't make decisions. We just give the information. We get information from the data, and eventually, if you want to have decisions, it has to be either a man or a computer. If it is a computer, is where it comes the artificial part of intelligence. Of course, in terms, particular for this area, we need in any decision point, we need either a physician or someone, an expert in the area, in order to move forward in some decisions, right? Because I mean, people like me, I mean, the knowledge that we have of medicine is limited compared to, I mean, the statistics or math. So if we do that, and then every decision we make, we are fitting it to, I put a cloud here, but to what I call the knowledge, and then we use that as one of the sources, and that's basically how we learn. So that's what we are learning, and then this is what we need the computer to do the somehow artificially. I'm going to hand over to my colleague just to talk a little bit about the roles and the different types involved in the data science process.
Okay, so this question is very important because if you are going to decide to use data science, you have to know what roles are involved in it. So in this picture, we are showing you a simplistic way to understand the data science process, okay? So if you look, first we have acquired the data, and then you structure the data, and then you have two ways to deal with data. You can display data and take actions of it, okay? And this, if you look, is a loop that, as Jorge talked about, generate knowledge, okay? So in the other option, you can analyze the data and make predictions of it. And the same process come out. So you have a cycle with these two approaches, okay? So who do this, okay? First of all, we have a data engineer, and data engineer basically is a guy that uses technology to organize data and make sense of the use of it, okay? And for displaying, it's a guy that called business intelligence, okay? So the idea to use business intelligence is to visualize how data looks and take this. It's more easy to take decisions with images against with tables. Okay, that's the idea of business intelligence. Okay, so for take actions, you have to work with a person that can make decisions to achieve good performance of the data. Why you are using it. So, as Jorge says, it's important to work with an expert to take these decisions, okay? And in the part of the analysis, you have a data analyst, a person that can understand the data and how to get good performance of it, okay? But always working with an expert. Okay, And finally, we have the data scientist. The data scientist is an expert person that can make predictions. And if you look in this graph, a data scientist may deal with all of these parts, okay? And the question here is, how do they do this? And look, there is many roles involved in this process, okay? So I think that you may hear about these technologies, okay? In programming languages, we have three main languages. R, Python, and Julia are the most famous programming languages to do data analysis, okay? And database management, we have MongoDB and some SQL, like MySQL or SQL server or something like that. There are many options. In cloud services, we have Amazon Web Services, IBM Watson, and Microsoft Azure. This is important because cloud services are used to deploy what data scientists do, okay? To deploy systems or platforms or something like that. Then we have, for data analytics or distributed systems, Hadoop and Apache Spark. The idea of these systems is to provide parallel processing, okay, to speed up the process of analytics or decision making. Then we have, for example, for dashboard and visualization, or what business intelligence guys do, typically use Power BI, Tableau, there are others, but these are the two main platforms to do this. Okay. So if you think about how we learn as humans, as Jorge says, this is the process that we use, and we can acknowledge. Okay, and the interesting thing here is that this is a cycle. You learn by doing again and doing again and doing again, and eventually you learn something, okay? The interesting thing is that a computer can make these too, okay? The area that deals with this is called machine learning. Here, learning is here, the word. So machine learning has two main problems to solve: supervised learning and unsupervised learning. And in this supervised learning, we have two sub-areas: the regression and classification. And in unsupervised learning, we have clustering, okay? So what means regression? The main idea of the regression is to fit a model that can explain the data the better way, okay? And classification, the idea, and this I think is that the most the problem that personal admin can be applied with data science, okay, or work together, is to chop off the data to produce labels or classification classes for some observation. Clustering means to get data and group using the internal data properties. Okay, this is not obvious. You can this is a group, but no, just the algorithm can do this. See, sorry, yes, the clustering. Okay, so if you think what means supervised learning, so supervised learning basically is used when you have a clear idea of what values can an algorithm produce. Okay. So the input for these systems are data. They do magic or something and produce something. But you know exactly what goal or what thing you want to produce with it. A good example applied to personal admin can be this. Suppose that we want to produce a system that tells me what treatment can I use for a new patient. And I don't know exactly what treatment I can use, but I know the information of the person, clinical data or something like that. What we can do is create a system that takes the data, this data, and the treatments that this person has taken in the past, and produce a system that can give me the treatment that I can use for it. Okay? So this means that we need many of these persons, of many data of many persons to produce this. Basically, the algorithm, what we'll do is we'll see how this new patient can fit to one of others persons or information that we have before. Okay. So in this table, we are showing you that last year was published a survey paper on how machine learning methods can predict some diseases. So you can see here the disease that has been predicted, the machine learning method that was used, and the accuracy. And the interesting thing is that here are many machine learning methods, okay? And many cases for diseases. So I think that use data science and medicine, we can do great things, okay? In the other hand, we have unsupervised learning. So basically, unsupervised learning is when you don't have exactly, or you don't know exactly what to expect about the data that you have. Okay, you know what values can produce the algorithm. So, like this picture, you can see the data, but after taking this and pass an algorithm to it for clustering, make these three groups. So the question is how this happen. So here, the idea is that the algorithm take the internal data properties to do this, okay? But that's not obvious for us. And imagine if we have many data, how this can be made. It's a complicated task, okay? So related, the research for this is that Kaliski take data from cancer, like that, has many observations on many variables, and he tried to get internal information of what we can produce with this. And the interesting thing is that they come out with three major cells type that produce this type of cancer. But the idea is that how they know that, they don't know that, yeah? Just the data give this information using clustering, okay, or unsupervised learning. Another good example for this is clustering imaging. This can be made with clustering too, okay?
I'm going to take it from here. All right, so, well, again, the whole idea is to start off with a good start just by just going through some of the topics. And in medical imaging, I'm pretty sure that some of you guys work on this area right now. But you know, something that is, why is becoming a thing and why is data science helping here? And I think, well, I want to show you the reason why a computer has no problems on, for example, finding a border here or a change here easily. It's because of the following. And I have here just in a black and white and a gray scale, but you know, all images are comprised by just three different colors, but I will take just the black and white scale, and we have a color from 0 to 250 for every color. And for a computer, knowing the difference between 134 and 135 is trivial, but for us humans, it's just impossible to see. So for us, probably knowing that there is a border here will be impossible, but for a computer, it's a big change. I mean, who doesn't know the difference between 134 and 135? It's a completely different number. But it's just impossible for us humans to see that. So the computer have to get involved in order to, you know, try to find these borders or you know, it's one of the big uses. So using things like this, it becomes trivial for a computer. Detecting some details is something that is not complicated for a computer. And I brought some examples here in general, in images in general, which, by the way, I have a couple of students I have a data science master's program that I run, and we have a course in computer vision. And I have them count how many stems of grass were in their backyard with with a camera. And they came up with really interesting algorithms that, it can be used for so many things. But by the way, one of the students started monetizing this algorithm, and he ended up putting a company on computer vision. But anyways, so this is more or less how this works. So any image is comprised by these three colors, the blue, red, and green colors. But what we want to do is, for example, let's take this image, and we have the histogram of any image. And for those who haven't realized that there's a histogram, and you have played with Photoshop, and there's always a histogram right there that we don't know what exactly it is, but it moves around whenever we move things around. So, and in terms of the statistics behind this is we have a distribution of pixels, and this distribution let's call it, let's assume that it's a probability distribution. And rather than have it like that, I would like to have all these pixels distributed in a uniform way. So from the statistics standpoint is, well, I just need to transform this random variable that is, I don't know, empirical distributed to a uniform distribution. I want to have something, well, this doesn't look like a uniform distribution, but definitely looks better distributed than this one. Because through this transformation, what is going to happen is that I'm not going to miss details. So I'm trying to move all this histogram towards, instead of having so much dark, try to push it, a little bit further to the right, or make it a little bit more uniform, and look at the difference in the images. And it's not easy. I mean, it looks better, but it looks way better in the computer, I can guarantee, because of the projector. But there are certain details, and if you can pass, and you can use this filter and use it a couple of times, and there are certain details that were just impossible for us humans to see that they were there. I don't know if you cannot see it because of the projector, I guess, but in the computer here you can here, yeah, it says Isuzu here. Anyways, it's something that it was just impossible to see in the left, and the math is so easy behind it. It ends up just to be a 255 times the CDF of the distribution, and sometimes it's trivial. I mean, it's really easy to do, and really easy to code. So what I thought about this, I was like, if this is the easy thing, I found a paper on it, speaking of medical imaging, right? The personalized medicine. I found a paper where a guy used a really simple clustering algorithm in, what was it? Epilepsy. And a really simple way, and then there were two sets of data points that were just there. And they came up with two different types of epilepsy with a really simple algorithm. So there are so many opportunities just by using trivial things that, I mean, what is going to happen when we come to the complicated stuff, right? Well, not that there are not complicated stuff already going on, but I'm saying this is just a quick example. Anyways, so just to wrap up, something that is really important, and I'm going to do whatever they ask us to talk about a little bit about the collaboration if we have a couple of minutes, or anyways, we will have some time to socialize, I guess. But there are great things, great opportunities of application of data science and in this area, and we can discuss research in case any of you want, and we can talk a little bit about in more detail what we do, and rather than having some general things, we have some more deeper things and some more deeper math. The computational power and the vast amounts of data are allowing to computers and physicians to work together in order to make more precise decisions. We are not getting rid of humans. We are just making decisions better, computers and humans. Physicians need to work together with data scientists, so let's say engineers, in order to extract as much information as possible from all clinical cases in order to continue to improve these current algorithms. Simple data science approaches are revealing important facts about clinical data. And a lot of people have told me, data science is the future and whatnot, and it's not the future, it's the present, and whoever is not into this is just running behind. Okay, I'm going to stop right there, and I'm going to pass it to you. Thank you very much.